All right, so my name is Angelique DeRoche, and I will be doing my final presentation on the Big Bang Theory. Okay, so when we hear Big Bang Theory, we automatically think of Sheldon and that show that I'm going to be honest, I have never ever watched once in my life because I kind of think it's stupid. But getting into the presentation, how do we get here? Why are we here? What is our purpose? There's so many questions that we ask when we think about the grand scheme of what the universe is, what it means, and how it started. People have been asking these questions for centuries. How could this work and how could something come from nothing? Because of the name and just talk in general, many people have come to the conclusion that the Big Bang Theory was an explosion that made the universe appear. The theory is probably one of the most well-known ones to explain our creation of the universe on a scientific aspect. The real concept was that all of space was stretching everywhere all at once. According to the theory, the universe was a tiny, infinitely dense and hot speck. Then at one point the universe started expanding at an alarming rate. This is what is widely known as the Big Bang Theory. Okay, so Georges Lemaitre, if I'm pronouncing that correctly, this guy was a Belgian cosmologist who initially proposed the idea of the Big Bang Theory in the 1920s. Because of this, he is known to be the founder or the father of the Big Bang. After this proposal, other scientists were compelled to add on ideas and other suggestions to the theory, um, which led us to Edwin Hubble, who we will get into in just a moment. Other notable observations, though, of universal expansion um, would be Alexander Friedman. He was actually the first who derived the equations of general relativity in 1922. And so we do get off a lot of research and information because of him. Um, okay, so Edwin Hubble. Who is this guy? Hubble was an American astronomer who made the observational discovery in 1929 that galaxies appeared to be moving away from us at speeds proportional to their distance. And so when you think of that in the grand scheme of things, it's crazy. Everything's so crazy huge, and so clearly it's crazy fast. Anyways, through this discovery, we come to what is well known as Hubble's law, which is the formula is recessional velocity is equal to Hubble's constant times proper distance. And unfortunately, I suck at formulas and math and a lot of stuff in general. So, okay, so we're going to move on to this diagram. And here we see a timeline of what happened during the Big Bang Theory. And so I'm going to go into detail about all these phases that are shown here. So basically, when the Big Bang begins, the universe is basically expanding rapidly and exponentially. It mentions here on the diagram that it goes from the size of an atom to the size of a grapefruit in a fraction of a second. Where a grapefruit may not seem that big, on a proportional aspect, the size of a grapefruit in comparison to the size of an atom is huge, and it shows the exponential increase. So, um, next we're looking at post-inflation. Basically, the universe is now just this scalding hot soup of electrons, and if you think about it, the universe is now a melting pot of all these super hot particles moving around and running into each other, mixing together. And so at point three, now the universe is rapidly cooling, in which allows the quarks to kind of mix together to form a into protons and neutrons, since quarks are basically the building blocks of protons and neutrons. The charged electrons and the protons are still too hot to form, and because of this, they're preventing all light from coming in, and it's just a giant hot mist or fog. So all of that is happening for about 3 minutes of time beginning. So now fast forward 3,000 years later, when the universe has basically cooled um, down to 10,000 degrees Celsius. Now, after all that time, electrons, neutrons, and protons are combining to form atoms. It's mostly hydrogen and helium, so um, because of this, the super hot fog is finally beginning to lift and light is finally beginning to shine in. With some progress, flash forward another 700,000 years to when time began. So finally gravity is starting to make all of these gases form to making gas clouds that create galaxies, whereas smaller forms of gas are collapsing within itself to form stars. These gas clouds are known as protogalaxies, which is a galaxy that isn't quite a galaxy yet. So then, flash forward another 14 billion years, the universe has cooled down to about negative 270 degrees Celsius, where the last phase of this diagram explains how these galaxies sort of pack together under a gravitational pull, and the first stars start dying out, where the stars essentially start to explode and expand into heavier elements in space. So these stars will essentially create new stars and planets, hence the heavy elements. So then comes the present day. Okay, so problems and challenges to the Big Bang. So we have to remember that the Big Bang is the theory that defines our existence, and that is a huge deal, but again, it's still a theory. So um, there are people who have challenged this idea, and when you think of it, it can make sense. I'm not sure where I stand on it, honestly. So I'm just gonna go into depth about the two main arguments that people have. So the first one would be that the Big Bang Theory violates the first law of thermodynamics, and the first law of thermodynamics states that you can't create or destroy matter or energy. The second point is that the formation of stars and galaxies violates the law of entropy. And the law of entropy suggests systems of change become less organized over time. So the Big Bang, it violates the rule that nothing can travel faster than the speed of light. Proponents say that at the start of the Big Bang, the theory of relativity didn't apply. Another response has been that space can expand faster than the speed of light because space is the domain of the theory of gravity. So basically, anybody who has criticized the Big Bang is shot down by proponents who just say, "Oh, the law of physics didn't apply then, so the theory still works." Um, it's pretty funny, but um, yeah. All right, and here are my references. I did reference the book as well, but honestly, like searching through these references were such a pain because the show actually kept coming up on Google Scholar, and I was getting quite angry. But thank you for listening to my presentation, and I hope 2020, in 2021, we get a turnaround and everyone has much better luck. Thank you.